So good afternoon, and thank you for being back on time. So we are getting ready for the next panel, which is the panel on the technical aspect, so dealing with end-to-end encryption and security of the service. So here I see, fortunately, that the panel members are already lined up, and our colleagues Dennis Sparas and Martin Haarses will monitor the panel. So over to both of you. Yeah.
Thank you, Rita. And as I know you all eagerly are waiting for this debate to start because we had a very productive and interesting morning. As Rita already mentioned, the idea of the afternoon now is to move a little bit more into the different technical aspects of Article 7. So in the morning we had a more general presentation of the main building blocks and the requirements, and now, as Rita already mentioned, in panel 2 we should be focusing more on technical aspects of interoperability, in particular in panel 2 on the end-to-end encryption and security of the service. So we will discuss different technical issues when it comes to Article 7 and what reasonable measures one can expect that the gatekeeper would be taking and what would need to be ensured in order to have an effective interoperability as such. We will have 5 panelists in the panel 2. First one is Professor Paul Rosler, who received his PhD in the applied cryptography at Ruhr University Bochum, and he is doing a lot of research in this area, and I'm sure we will be very interested to listen to his presentation. Then we will also have Eric Rescorla, who is Chief Technical Officer in the Firefox team at Mozilla. He joined Mozilla in 2013 and has been focusing since then on advanced technologies and Mozilla's different technical strategies. Then, as a third panelist, we will have Alisa Cooper from Cisco, who is a Vice President of Ecosystem Engineering and who is Fellow at the Cisco Systems. She also served previously as Vice President of Technology Policy and Vice President of Technology Standards at Cisco. As a third panelist, we will have Matthew Hodgson from Matrix, who is a technical co-founder of Matrix and CEO/CTO of New Vector, the company which was formed in 2017. And essentially, he's involved in the day-to-day job at Matrix, and I'm sure we will be very eagerly listening to his presentation and demo he will hopefully be able to show us. And then last but not least, we will have Stephen Hurley from Meta. He's Associate General Counsel at Meta, where he leads the EMEA team, which is responsible for telecoms and messaging services. And without any further ado, because I'm sure you're more interested to listen to panelists than me, I would invite Paul to start his presentation. I think you have more or less 15 minutes.
Okay. Introduction. Yeah, I will just directly dive into the setting. We heard about the setting already a little bit today. We have 2 users, Alice and Bob. Alice on the left side, Bob on the right side, and the problem is that they are using different applications to communicate, and basically they also have different providers for communication. And so the question is, how can we make them communicate together? The first step that they need to overcome for Alice specifically, if she wants to start the communication, is that Alice doesn't know which provider Bob is using. So there needs to be somewhat a service that tells Alice how to contact Bob and which provider Bob is actually using. The second step after she learned which provider that is, she will try to get information about Bob that is of technical nature in order to start encrypting payload on a secure channel from Alice to Bob. So that would be the second step, namely getting some public key material, for example. This is just technically necessary to start an encrypted conversation. Those 2 aspects won't be the focus of my talk and probably also not the focus of this panel, but it's important to mention that those 2 steps are necessary. The third step is now the actual communication, in which Alice encrypts some payload, sends the resulting ciphertext probably directly to Bob's provider, and Bob's provider will forward that ciphertext to Bob, who can then decrypt that ciphertext to obtain the actual payload message. An alternative to that would be that instead of sending that ciphertext directly to Bob's provider, Alice first contacts her own provider, who then forwards that ciphertext to Bob's provider, who will then forward it eventually to Bob. That's the overall idea, and we will see that this second approach, in which we use both providers to forward a ciphertext, can offer slightly better security properties, potentially. And before I speak about security properties, we would need to know what are the requirements. We have heard some of them in the first panel already. I will just briefly summarize those that are important for at least my talk, and probably also for the rest of that panel here. The first requirement is very explicit in the DMA in paragraph 3 that says the level of security, including end-to-end encryption, shall be preserved compared to what is reached in the inter-provider communication of a gatekeeper. So what that basically means is that ciphertext sent from Alice to Bob do not reveal any information on the contained payload messages, and probably not only that pure level of confidentiality, but every level of security that the gatekeeper provides to its own users. And that may include something that is called forward secrecy, or maybe even post-compromise security. There are many other notions of security that modern messengers, including those of the gatekeepers, provide today already. And those security properties go far beyond what pure confidentiality is. And we see in practice that very efficient, widely deployed building blocks suffice to reach levels of security that are desirable and that go far beyond just pure end-to-end encryption. So that's very important to mention here. The second property that I call metadata protection is, from my perspective, captured in paragraph 8 of the DMA. And that paragraph 8 says that the gatekeeper shall collect and exchange only the personal data that is strictly necessary to provide interoperable communication. And one flavor of that metadata protection, from my perspective, could be that ciphertexts sent from Alice to Bob do not reveal more information than technically necessary, including the identifiers of the sender and or of the receiver. There might be technical requirements that always at least one of the two identifiers is revealed to those nodes on the route from Alice via the providers to Bob will be revealed, but hopefully not at any point not both of them. Because if both identifiers are revealed, then we don't win a lot of privacy or security due to the DMA, because whenever both identifiers, the sender and the receiver, are revealed, then we reveal basically the social network of all the users. And so we should refrain from revealing that social network whenever possible. And I will tell you within my talk that there are practical measures, practical protocols that help us to actually hide that social graph very efficiently in most cases. The final property that I want to talk about is abuse prevention. We will see more about that in the third panel today, but I think it's important to see that these three properties are somewhat interdependent and also relating to each other, depending on each other, linked to each other. And so I want to mention that the gatekeeper, according to paragraph 9, is permitted to take measures to make sure that its users are not endangered with respect to integrity, security, and privacy. And what I interpret into this is that, for example, spam filtering should be enabled. Also, if abusive content is received by a user, then the user should be able to report that content, and the abusive sender should be blocked from a platform. And probably you can imagine that these three properties are somewhat dependent on each other. Okay, so those are the basic requirements. How can we implement the DMA in order to achieve these three goals? I see two possible approaches that are somewhat alternatives. The first one is that the protocol for interoperable communication mostly depends on the gatekeeper's core protocol. So the gatekeeper's protocol is the basis for communication, plus some additional tools that make sure that interoperability actually works. And the second alternative would be that we develop a new protocol that is standardized from scratch and probably not each gatekeeper speaks with its own non-gatekeepers with their own protocol, but all the gatekeepers use the same standardized protocol. Those are the two alternatives that I see. We will hear more about more fine-grained taxonomy and variations of these two approaches in Matthew Hodgson's talk later in our panel. And we will hear more about the standardization approach in Alyssa Cooper's talk. I will focus mostly on the gatekeepers core protocol approach here. And what that means is that basically all the arrows, so all the protocol flows that we see here, will depend on what the gatekeeper's core protocol already does today for internal communication, inter-provider communication. That means that the gatekeeper needs to specify an API, a documentation, and probably even provide a library that the non-gatekeepers can include in their applications. And so their applications can basically call that library, and the library then communicates with the gatekeeper's provider and makes sure that everything works. That could be an option, and we will see that there are some components that need to be changed on the protocol layer, which is the +X on the first line of my slide. But we also see that there are a couple of changes that need to be done on the server side. One of the changes that needs to be done is that we need to replicate the key distribution, because although the non-gatekeepers already have some public key distribution for their users, we can't mix the key material used for their intercommunication or inter-provider communication with the key material used for interoperable communication. So if we follow that approach, every non-gatekeeper has to replicate their key distribution service as many times as the number of gatekeepers that non-gatekeeper wants to speak with. The second change on the server side is that, of course, both the gatekeeper and the non-gatekeepers have to implement forwarding services. So ciphertexts need to somewhat reach the recipient of a ciphertext. And finally, we have to make sure that abuse prevention and spam filtering somehow work, and that could work in a cooperative fashion, in an interactive fashion even. That are the basic ideas. Okay, so going to the standardization of a protocol, what we need to do is we need to develop all the components that are not existing for inter-provider communication. We need to develop these from scratch. There are a couple of ideas laying around. Many of them suit pretty well, but I think a couple of adaptations need to be taking place. One important aspect is that the new protocol needs to be at least as strong as the best gatekeepers protocol, because the DMA requires that the level of security is maintained for interoperable communication. And so that interoperable communication protocol needs to be as strongly secure as the best gatekeeper one, because otherwise the best gatekeeper's internal protocol is stronger than that one, and so the interoperable protocol can't be used. What is important, especially from my perspective, is that simple updates of the new standards need to be doable. And that includes that standard keeps as little legacy as possible, and that standard doesn't start with a solution, but rather specifies the requirements first. And as we see probably in my talk already, there are a couple of aspects that need to be considered before we start with developing a solution that works for all cases. One aspect that I want to mention is that since different gatekeepers may have different policies or approaches to prevent abuse, that standardized protocol needs to handle these different measurements or these different abuse prevention techniques. Okay. That's first of all, on a high level, what I want to mention. The second thing that I want to talk about now is that confidentiality, privacy or metadata protection, and abuse prevention, those three things are interdependent. And for a good protocol, we need to make sure that an interoperable protocol combines these three properties. Okay, so how do we do that? First, what we want to have, I said that before already, is that we want to have pure message delivery from Alice to Bob. And we want that that message delivery is confidential, plus additional properties like forward secrecy and so on and so forth. And that's fine. We have protocols for that. That's definitely not a problem. But we also want, and that was what I wanted to highlight in the very early slides of my talk, that those communication is also somewhat private or metadata protecting. And those normal channel protocols that provide message delivery are not very good at hiding the metadata. For example, WhatsApp's internal protocol only provides the actual payload. It doesn't protect any metadata like the group name or the sender or the recipient, the time when something was sent, and basically the entire social graph is revealed. So one simple solution, and I don't want to go into the very technical details, we can discuss that later if somebody wants to, but one solution could be that Alice, for starting and establishing a secure communication and private communication with Bob, would first establish a confidential channel with Bob's provider. And then, when sending her message to Bob, she only sends the information to her own provider that the ciphertext that she sends should be forwarded to Bob's provider, without saying that they are actually targeted to Bob, who is the recipient. And so the result is that due to that flow, Alice's provider never learns who the actual recipient of that ciphertext will be. And that means that in that case, we already provide privacy of the recipient. We can continue that by building a second channel into that first channel that is now spanned from Alice to Bob inside that first channel. And in that, on that second channel, Alice tells the recipient provider, Bob's provider, that that ciphertext should be forwarded to Bob. But that ciphertext does not include information from who that ciphertext is coming from. And as a result, that ciphertext doesn't tell the recipient provider who the sender of that ciphertext was. And so we achieve with very simple channel techniques that are deployed in practice, used by billions of users every day today. We achieve metadata hiding very, very efficiently. And so I encourage the people who will develop those protocols to make sure that we achieve these very simple properties. Okay, inside that second channel, we actually then embed the third channel, which was the actual communication channel from Alice to Bob that provides confidentiality and all the other very strong confidentiality goals. Okay, so that's the first thing, but we kept in mind that we also want to achieve something like abuse prevention. So the first thing that that Bob wants to do is to report abusive content. And what Alice could do in order to make sure that she doesn't have to reveal her identity towards Bob's provider or Bob's identity towards her own provider is that she has some kind of a certificate that tells anybody on the route that she's actually permitted to send those ciphertexts. She received that ciphertext at some point from Bob, and again, this certificate approach is established in practice. It is used by widely deployed messengers, and so we don't have to worry about efficiency or practicality here. So what Bob would do when he receives the abusive content is he would report that, and he would say that the certificate that was attached to that abusive content will now be revoked. And so after revoking that certificate, Bob can effectively block a user who sent one's abusive content. But we also want to have blocking of users entirely from the platform. And for that, I believe that the providers will interactively cooperate, ban abusive users. That's, I guess, also not a problem. All providers are happy if they have a somewhat friendly environment. And so I guess that's an issue that is rather non-technical. Finally, we want to have spam filtering. Also, that can be implemented on one of the two sites, very technically efficient and simple. Okay, so that was more or less on the trade-offs between confidentiality, privacy, and abuse prevention. Some final words about group messaging. That's also a requirement of the DMA, and I see a couple of alternatives how that can be implemented. I will walk through them very quickly. The first one would be that we can use the pairwise channels for two-party messaging and just let all the group members communicate via their pairwise channels. That is extremely simple and super easy to deploy. There are protocols in the real world who use that approach, but of course it's slightly inefficient if the groups become bigger and bigger. So an alternative would be that, again, the gatekeeper's core protocol is used and all the outsiders, non-gatekeeper users will speak somewhat that gatekeeper's protocol. A third alternative would be that we connect the provider's subgroups, and inside a provider, the users speak their internal protocol. And a fourth version would again be standardizing a protocol that all the users, both non-gatekeepers and gatekeeper users, will speak. Problems and solutions that I see here is, first of all, that we need to have somewhat a consistent group membership management that is super important and usually requires a central instance that makes sure that actually everything is consistent. That could be the gatekeeper, it could be a trusted third party, a non-gatekeeper, or somebody else. And a second question that I see here and that should be tackled is that what happens if multiple non-gatekeeper users or basically multiple users from different non-gatekeepers or different gatekeepers want to build a group. That's something that is still ahead of us, but we have to keep it in mind. Okay, final very short conclusion slide is that I think that confidentiality, privacy, and abuse prevention are practically achievable. And as far as I read the DMA, they are actually required to be compatible among each other as far as technically possible. And I don't see big issues there, only that it hasn't been built yet, but all the tools are available. There are a couple of questions that I think need to be discussed probably in that panel today or also in the extended discussion, which is, should we use the gatekeepers' freedom to choose their or use their own protocol, or should we standardize a new protocol? There are a couple of trade-offs, for example, replication and implementation overhead, if there are many different gatekeeper protocols being used. A standardization overhead is, of course, also significant, so that might be a counterside. Agility is very important, and we heard the question earlier today that right now the competition between the messengers is pretty lively, and that is something that drove the security in the messaging domain. Also, group efficiency is something that is important, but what I want to close with is that everything that I talked about and all the questions that I see, at least from a cryptographic technical perspective, can be realized with tools that are deployed and used by billions of users every day. Thank you very much for your attention.
Thank you, Paul, for this very interesting introduction and already kind of hinting to some of the questions that we should probably deal with. I think I will give the floor to Eric now, and I'm sure he will have some replies already.
Thanks. Thanks, Paul, for framing that up. That's fantastic. Okay, is it this button? What's the button?
This is PDF.
Oh, it's PDF, so it doesn't work? Oh, you can, next slide, please. So I wanted to start with a bit of an eye chart here. This is the interop matrix for a protocol called QUIC, which was standardized in 2021 after about 5 years. What you're looking at here is the matrix of which implementations can talk to each other. Darker is better, lighter is worse, white is really bad. This is draft 20 of QUIC, very shortly before it was standardized, probably about 4 years into the process. This is the product of maybe several thousand hours of people sitting in rooms trying to get a specification which was as clear as possible and which interoperated properly, and quite a bit of people sitting across from each other saying, "Excuse me, what do you get at key stage number 10? And does it start with a 1 or a 2?" The reason and as I said, this is the product of an effort to make the specification as absolutely clear, crystal clear as possible. I wanted this as a reference point for the rest of this conversation because I think it level sets the difficulty of getting this right when people are trying very hard. Can I have the next slide? Oh, which I press this button now? There we go. Just the wrong way. Yeah, okay, awesome. So maybe I'll start with the big picture here. So if we're going to have end-to-end encryption, that means that the protocols themselves have to be end-to-end. And what I mean by that is if I'm going to encrypt data from you to me, we have to share a key, and that key has to be established end-to-end. It can't be gatewayed by some intermediary. So we need end-to-end key establishment protocol. if I'm going to send a message encrypted from you to me, or me to you, since it's going to be encrypted, it can't be translated, which means I have to send it to you in a format you can understand. And if we're going to do voice or video, then that media has to also be in a format that I can send and you can receive. And all those things have to be end-to-end, otherwise it doesn't work, which means that the clients have to do all the work of making sure that the media of whatever it is interoperable. And that means they have to have common protocols. That applies whether they're standardized or whether they are dictated by some gatekeeper. Now, some gatewaying is still possible, as Paul indicated. So for message transport, you can do gatewaying. So I may send my message up to like my provider and they send it to you. And maybe identity system may or may not be gatewayable, depending on exactly how it's designed. There are a number of designs here. In any case, these are all very semantically complicated image interfaces. So the design of the key exchange protocol alone is quite complicated. The messaging is quite complicated. I'll talk about this as we go. There we go. Clearly going to need some kind of, as Paul said, a key establishment protocol. The good news is there's quite a lot of cryptographic prior art here, starting with things like OTR and Signal, and now with a new ITF MLS specification, which is going to be published any day now. Unfortunately, there are also a lot of failures. And if you just look at the history of these systems, there have been a lot of publications of breaks of various kinds of key establishment protocols. So they're hard to design, they're hard to implement it. As I said, it has to be implemented in the clients. This also brings us to the question of group messaging. As Paul indicated, there are several designs here. One is what he called, I think, pairwise. I would call full mesh. This is really, really inefficient for large groups. When MLS was being designed, one of the main pieces of feedback we got was that the current protocols were too inefficient for large groups, and it was a real problem. It's also a real problem for media, as I'll talk about shortly. It is, however, kind of robust in mixed settings where you have two protocols running concurrently, which you might imagine having. Really, the more attractive design for a group system is to have a single protocol, which is spoken by every member of the group. Unfortunately, the one problem this creates is if you have a system where there are multiple concurrent sets of requirements, as Paul started indicating, you're trying to join them, it's really hard to know what to do. And I'll talk about that a little bit shortly. So I keep forgetting which version is which. The media is a sort of similar story, right? It's encrypted, so it can't be translated. And I have to know exactly what the receiver can and can't receive. There's also a lot of prior art here. Even non-interoperable video conferencing systems and IM systems very often use interoperable pieces like MIME or RTP. But these pieces themselves are extremely technically complicated. They're not as brittle as a crypto in the sense they don't fail catastrophically. They just fail in gross kind of unpleasant ways when they fail. So you get echo, or you get glitching, or you get like things you can't decrypt or something like, or can't display or something like that. So all these need to be carefully defined. From the perspective of the DMA requirements, it will be necessary to define a set of core interoperable features and an extensibility model that describes the things that actually need to be implemented in order to have a compliant system. And an extensibility model in the sense that when a gatekeeper decides to roll out a new piece of functionality, how that behaves for access seekers who do not currently implement that functionality. How does it fail gracefully as opposed to ungracefully? As Paul indicated, there's this question of identity. Currently, each gatekeeper is its own closed identity system. This is true even if the names that the gatekeepers are using appear externally referential. So very often systems use E164 numbers, but it's also common to have situations where multiple providers use the same E164 number for the same person, and it's not clear in that case, which if you start with the E164 number, which provider you should be talking to.
Phone number to those that don't know the spec.
Thank you. Well, I forgot to fix that. Okay. Secondarily, even without that, we have the question of how does system A authenticate users to system B, and how do they appear? So in particular, say I have say the gatekeeper uses E164 numbers, and so does my system. When I attempt to communicate to them, do they appear in the gatekeeper system as if they were native to the gatekeeper and they had the same E164 space? and they collide with the same user who might be using the same number in that space. So if, for instance, if I have an account on access seeker and an account on the gatekeeper, and I attempt to communicate with somebody else, do that appear as the same user or different users? So all these become like real problems. Finally, with this question of how do we detect misbehavior, currently the models, the security models for identity on these systems are extremely weak and do not do a very good job at all of detecting what you'd call in the web PKI world misissuance, which is to say the gatekeeper allowing someone to impersonate somebody else. And that's one thing when you have a closed system. It's quite another when you have an open system and the gatekeeper has 50 access seekers, all of which are allowed to inject into their identity system in some way. It's interesting, by the way, to make here an analogy to telephony, where the numbers themselves route directly to a location. That is not obviously the case here. And it also goes back to something that was discussed in the previous panel, which is the level of required transparency. So in a telephony system, if you port your phone number from one provider to another, that's simply an invisible operation. But it's much less clear here what the behavior ought to be if you attempt to port your identity from one gatekeeper, say, to another. Another situation which seems extraordinarily problematic is multiple gatekeeper scenarios. Paul alluded to this earlier in his conversation, where you might have a group message with two sets of gatekeepers. In the version where the way you get access is by adopting the gatekeepers' interfaces, will the gatekeepers themselves adopt each other's interfaces? Will they be required to? Will they be required to make it interop at all? If you want this to work seamlessly and want it to work well, they will have to be required to. Otherwise, you'll have a problem where you might have a situation where it only works if you talk to one gatekeeper at once, but the gatekeepers themselves don't interoperate. If you do without very clear guidance here about compliance, the burden is likely to be on the smaller players to make it appear to work, and it often will work badly, and will be a really inferior experience. This brings me to a final, I think, set of points, which is about the guidance that I think was necessary to make this project successful. So this is supposed to be non-exhaustive, but I think might help clarify. So first, I think one important value is transparency, which is to say that we discussed earlier the topic of reference offers. The reference offers, the protocol specifications need to be like absolutely clear and absolutely detailed, in sufficient detail that anybody can implement them. And that's, as I was trying to allude to earlier with my QUIC example, this is a very, very hard problem to write such a specification. And unlike in the case of QUIC, the level of incentive the gatekeepers may have to do a good job here is somewhat lower. Once those specifications exist, we have this question of reliability and stability. Namely, will those interfaces remain stable for long enough for people to implement them, and stable long enough that if changes happen under the covers, that the access seeker will still be able to have access until they have time to catch up, rather than having changes that cause breakage instantly. So you clearly need notification well in advance of any kind of breaking changes, and some extensibility mechanism for handling non-breaking changes. The final 2 points go to the ability to the access seeker to develop their own interoperable implementation. First, you need a level of testability that really goes beyond, I think, what you largely have seen. As I was saying earlier, when the difficulty of getting interoperable systems to work interoperably often requires very tight collaboration and very good understanding of what's happening on the other side. This is especially true for cryptographic systems, where failures often appear opaque. So you just get, I can't decrypt, rather than seeing some sort of specific error. And when debugging those systems, what you generally need is extremely detailed access to what is happening on the other side. So you need like log level access or even memory level access to say, okay, I went through the key hierarchy, and at this point, I got this key. Did you get the same key? And if you don't have that, basically, you're just screwing around, guessing what might make it work, and like probing it like an oracle. Every time I've done successful interoperability testing, which I've done many times, it always looks like two people sitting across the table from each other, saying, "Okay, now what?" So that's one possibility. The other possibility is to get publicly available test servers or reference implementations which you can yourself download that implement every crucial feature of the protocol, every essential feature, so you can verify interoperability yourself. It's not sufficient to test against live servers. That simply doesn't work properly. Because the live servers need a level of opacity, and a level of secrecy, and a level of operational complexity that you cannot do interop testing with at the very initial stage. And finally, this requires a level of support from the gatekeepers that invest time and resources to make available to access seekers the assistance they need to build an interoperable implementation, so that when the previous things fail, when the specifications aren't clear enough, when they're not stable enough, when you can't do interop testing and verification yourself. There's someone you can call on the phone and say, look, this doesn't work, help me out. And I think without those things, we're simply not going to have a successful project. I'm sure there are many other things, but I think those are the key points that I would hit. Thank you.
Thank you, Eric, in particular that you very nicely, outlined the key issues and the big picture, but then went into the details and also provided some food for thought on the possible solutions, even though I understand your list is non-exhaustive, which is a bit scary, but I'm sure Alisa will have some ideas on the other part of non-exhaustive list.
Yeah, we'll see. I think the list will continue to get longer. So thanks. I think this has been a great setup. So I'm Alyssa Cooper. I work at Cisco. Cisco provides a full-service voice, video, and messaging collaboration suite. You might know it as WebEx. Some of you may have joined a WebEx meeting. There's also a messaging component of the product. And for those who are joining us online, Slido is also part of the WebEx collaboration suite. I also co-chair the brand new More Instant Messaging Interoperability, or MIMI, working group in the Internet Engineering Task Force. It's a group that has just recently been chartered to develop the building blocks needed for interoperable messaging on the internet, and was very much triggered and motivated by the adoption of the DMA. So I'm going to talk today a little bit about how we can center the desired user experience as a driver and a component for the commission and the community to think about as compliance with Article 7 starts to be evaluated. And I will use enterprise interop and enterprise experience as kind of the motivating example for that. Let's see, there's only 2 buttons. You would think it wouldn't be so hard. Okay, one of them doesn't work. So when we think about collaboration and messaging in particular in the enterprise, there's already a lot of enterprise interoperability today. And there's essentially 3 main modalities for that. The first is direct integration. So in some cases, we as WebEx will integrate directly with other competitors in the marketplace, so that, for example, you can launch a WebEx meeting from a Teams client, or have other kinds of interop that way. Another option is to gateway. So we use Mio as a gateway provider. Mio consumes the published APIs of WebEx, Slack, Zoom, and Teams, and allows for messaging interoperability across those services, so that as a user of one service, you can easily message users of another service. This happens in clear text. It's not supportable for in the presence of end-to-end encryption, as Eric was talking about. And then we have standards-based interop. So we support WebRTC and SIP-based interop, so that you can launch a Google Meet meeting from a Cisco device, and so on. And we've adopted MLS into the WebEx portfolio. We use MLS group keying for end-to-end encrypted meetings within the WebEx user base. And we're hoping to have further adoption of MLS and what comes out of the MIMI working group in the future for standards-based interop. So there's already a lot of this out there today, and that kind of begs the question of why. Why do enterprises care about this? And the reason is that enterprise collaboration is already a multi-platform world. So most IT departments are already supporting 2 or more different collaboration platforms inside a single enterprise. And that might be because they have teams with different requirements or different cultures. It might be because of acquisitions, or because different teams want to trial different things. But from the enterprise user and administrator perspective, what they really want is uniformity of experience. So they want, as an administrator, to be able to apply uniform enterprise policies across all of these services for security, for privacy, for data loss prevention, for compliance. It's not really tenable to have those kinds of things supported to different levels just because you have one group in the company that's using a different product. They also want to have a seamless user experience across these products to drive productivity and collaboration and efficiency. So within a company, we shouldn't have to spend a lot of time haggling over whether we're going to use Slack or Teams today to resolve our important business matter that we need to discuss. We should just be able to use whichever tool is comfortable for us and have that work seamlessly. So there's a lot of drivers already to achieve enterprise interoperability, and much of it is derived from what the user wants and what the customer wants. If we think about Article 7 compliance under the DMA, I think there's a couple of different ways that we can think about this. The first is a narrow conception, and we've heard a little bit about this already today. So you can imagine that we have a sort of minimum functionality that gets supported by a handful of gatekeepers in order to be in compliance with potentially a handful of requests that will come from what people have been calling access seekers, but I call them competitors because access seekers is a very difficult phrase to say over and over. So I'm going to call them competitors. So let's say we have a handful of competitors, they request interop with a handful of gatekeepers, and the gatekeepers provide the absolute minimum that they need to in order to be in compliance with the letter of the law. I think this approach ignores three really important things. The first one is, as I've been discussing, user experience and user requirements. What the actual end user, the end customer, is seeking when they say they want interoperability. The second one is the development and maintenance burden that this kind of approach puts on the competitor. It's just if you take the minimalist approach, you don't really contemplate what that burden is. And then the third one is the security implications of the resulting overall system. So if we look at what the DMA says, it requires gatekeepers to, quote, render the basic functionalities operational. That gives the providers really wide latitude to, build interfaces that result in a set of systems that aren't necessarily usable by the end user or the end customer, that don't meet the user requirements, and that don't really speak to what the security of the overall ecosystem is as a result. On the other hand, you could take a broader view, and we could think about the timeline for the DMA Article 7 compliance and realize that over the next 5 years, these obligations are going to be coming into force, and look at that as an opportunity to lay a foundation with the initial requirements to build building blocks that then get reused as the later requirements come into play. It's also an opportunity to center the user experience in evaluating how compliance is achieved. Do the gatekeeper solutions actually incentivize users to want to use the interoperable services as opposed to disincentivizing that use? And we've seen a little bit, some examples and kind of ideation around what the user experience could be like. It's also an opportunity to consider the systematic security implications of the changes that are going to be made by all the actors in this system. So again here, the DMA requires that the level of security is preserved in any given pairwise relationship between a gatekeeper and a competitor. But it doesn't really consider the broader system effects on security and the need for the security properties of that broader system to be able to be analyzed and vetted and evolved over time. So I think taking a broad view will land users in a better place, both from an experience perspective and from a security perspective. And I'm going to go to the next slide and have a little bit of analysis of kind of idealized scenarios for this. It addresses both one-to-one and group messaging, and that's for a few reasons. The first reason is that we have 0 customers who ask us only for end-to-end encrypted one-to-one messaging. Like, that doesn't really exist. Nobody only wants this for one-to-one. If you want encrypted messaging, you want it whether you're talking to 1 person or 2 people or 1,000 people. So if we're thinking about this from the user perspective, we should be thinking about it for groups. It's also the case that for many system designs, one-to-one messaging is just a subcase of group messaging. And again, if we want to be kind of laying the foundation for the next few years of how we build these things, then thinking about a group messaging solution which also functions well for a group of size 2 is probably a better way to go. So if we look at the end-to-end encryption solution space, I think there's going to have to be some evaluation of the trade-offs that come when we start to have solutions that are offered for the compliance deadline. And I wanted to look at a couple of idealized scenarios and think about those implications. So in the first scenario, we have gatekeepers that adopt their own bespoke solutions, and both Paul and Eric have talked about this already. But at a high level, the benefits of this approach are that these are easiest for the gatekeepers to implement. So fewest number of changes potentially that the gatekeepers have to make if they adopt their own bespoke solution. Also requires the least amount of coordination between them and any other external parties. So simpler from the gatekeeper's perspective. And there's kind of two different ways they could go here. They could go a sort of SDK and library approach, or publication of an API, or potentially both. If we think about the SDK or library approach, what this means is that the competitor is taking on the gatekeeper's security vulnerabilities, and basically become at the whim of the gatekeeper to patch and to maintain the security of the library that they're adopting into their own software. And speaking as an enterprise provider to some of the world's largest businesses, this is the kind of risk that we are extremely unlikely to ever take on, to embed somebody else's software in our software. If we think about the API approach, it's better on that front in terms of taking on less unmanaged risk. But this still introduces complexity with each additional API that, as a competitor, you have to implement. So if you want to interoperate with 3 different gatekeepers, as competitor app Y here is in the image, then you're building a lot of new complexity into your competitor application. And I think from this perspective, there's really no credible story towards either inter-gatekeeper interoperation or to group scenarios that involve multiple gatekeepers. Just it's not really feasible from this perspective. This also creates kind of a nightmarish scenario from a security perspective. If I'm an attacker in this situation and I manage to find a vulnerability in one of these solutions, now I'm able to expand that attack surface to many, many more competitor applications because they've all embedded that functionality or that library into their software. And so the patching is much more complicated because we now all have to patch in order to regain the security that we had before. But the attacker still only has to find that one vulnerability. It's also unclear in this scenario if the reference offers will create the possibility for third parties to conduct rigorous security analysis. So this is not something that's strictly required by the DMA. And it's unlikely to happen if it's not strictly required. And the last thing I'll say about this situation is that it basically puts the gatekeepers in a situation where they can constantly attempt to disadvantage their competitors by making it implementation kind of difficult, costly, and that might be subtle or it might be explicit. But this puts a lot of control in the hands of the gatekeepers to be able to disadvantage their competitors. We were talking earlier today about the sort of legacy of interoperability requirements in telecom, and I think we have a lot of experience with these kinds of scenarios. So the one that came to mind in preparation for this panel was with local loop unbundling for telecom and for broadband. Literally 2 decades of experience with that, at least, if not more. And throughout that time, we've seen over and over how the incumbent will attempt to make the interfaces difficult to actually effectuate in practice, make it hard for their competitor to actually be able to offer the service that they want to offer because they have so much control over what that interface looks like and how it's accessed by the competitor. So there's another way, which would be a consolidated solution, also previously referenced. And this could be a standardized solution, could also be a library, could be some combination of those two. The nice things about the consolidated approach are that they equalize the operational burden. So everyone will have to make changes. The gatekeepers will have to make changes, the competitors will have to make changes, potentially significant on all sides. But it's not an asymmetric burden in terms of the development and maintenance obligation. There's also like a much more obvious pathway to groups, to multi-party, to multi-gatekeeper, if everyone is sharing a protocol interface or a library. If we are talking about the adoption of a common library here, then certainly we still need to track the vulnerabilities in that library. It's not like having a common library eliminates that possibility. I think we're all familiar with that. But at least that would be a consolidated exercise and not a distributed one. And if we go down the standardization route, as Eric was talking about, it gives us the opportunity to develop multiple interoperable implementations and to learn through that process of trying to achieve interop between different implementations. It's a nice benefit that you get from having a single standard. I think the consolidated solution also reduces the enforcement burden for the commission, because instead of having to kind of micromanage and look in detail at every different bespoke API that the gatekeepers come up with, we have a more consolidated interface to look at and try to think about how they're actually meeting their obligations under the DMA. If we do go down the consolidated route, which I hope as an industry we will, some things to be on the lookout for, and these to some extent overlap with what Eric was talking about. So we want to have an open and complete specification for a couple of reasons. Absolutely necessary in order to be able to deploy and develop interoperable implementations. Also want it to be sufficient for formal security analysis, where we actually systematically check the security properties that are meant to be guaranteed by the solution. The next one is to think about the trade-offs between group scaling, security properties, and application features, and make sure that they're meeting reasonable user expectations and common use cases. There's obviously multiple different approaches that are already out there in the market today, and they deal with this trade-off in a different way. So if we're going to consolidate down to a single or small number of solutions, we definitely want that trade-off to be meeting the vast majority of what users are looking for in terms of use cases. We've touched a little bit on identity here already today. Definitely want to have it such that our consolidated solution has compatibility with end-to-end identity. So you want to understand how are we going to go from our cryptographic identity to our human identity, and have a mappable path towards that. And I think as we're thinking towards the future, we also want to have a pathway to support post-quantum algorithms in whatever consolidated solution we adopt. So I think these are just, throw those out there as things to think about for the future as these solutions get developed. That's it. Good luck with your demo.
So Matthew, now you will show us how interoperability works, right?
Right. Hi, everybody. I'm Matthew Hodgson. I'm CEO and CTO for Element, but I'm here with my Matrix T-shirt on today to talk about, hopefully, concrete options for implementing the DMA. Now, I hasten to add that this is done in a standards agnostic fashion. So whilst Matrix itself is an existing 8-year-old protocol for decentralized secure communication, basically with not trying to do a demo here specifically about Matrix, you could swap out Matrix for XMPP, you could swap it out for whatever comes out of MIMI, and I should mention that we're working with the folks on the MIMI IETF initiative to see if Matrix will fit some of the problems to be solved there. But I basically wanted to present a concrete taxonomy and a bunch of examples for how you can think about this, both from the gatekeeper's perspective as well as the requesting party perspective. So we've got 4 options to play with here. You can think of these independently, or you can think of them as a progression. The ones which we've identified is that you can start off with what we call client-side bridging, but using server-side APIs. So this is a concrete app that you go and install on your phone that goes and effectively liberates your communication from a given gatekeeper and allows you to interoperate with the wider DMA-compatible network. That could be using a protocol like Matrix or MIMI or XMPP or RCS, etc., or it could indeed be the more fragmented approach that Alyssa just outlined. Then the second extension is that rather than connecting through to the gatekeeper on the server side, this app that you've installed, let's call it a bridging app effectively, would just talk directly to a gatekeeper app which is already there on your phone. And I'm going to go through these in more detail, so don't worry about tracking at this point. And the third one we're calling a Polyglot app, or possibly a multi-headed app, which allows the gatekeeper app or other apps to talk through to both their kind of legacy walled garden environment, as well as a more open DMA one. And then the fourth extreme is that the gatekeeper switches to an open protocol in the example that Alyssa just gave on the right-hand side. In the presentation here, we are looking at using an open protocol, again, agnostic to what it might be, but then the first three of these are certainly valid for any other protocol too. So, I apologize that there's going to be a bunch of arrows and diagrams. It should not be too scary, though. So the core problem we see to be solved is that we have Walter on WhatsApp, and we're picking gatekeeper names at random here. Apologies to any named gatekeepers, who is down on the left-hand side. He's just on WhatsApp. He doesn't care about interoperability. He wants to keep using WhatsApp and talk to people on WhatsApp. And then you've got Martin on the right-hand side, who happens to be, say, on Matrix. So it could be, again, any requesting party. But he wants to talk to people on WhatsApp, but he really doesn't want to install it. How does Walter and Martin talk to one another? So here is scenario one. In here, we've got a new user called Bob, who's going to be our victim for demonstrating client-side bridging. He's already got WhatsApp installed, but he decides that he wants to talk to people who are not on WhatsApp. So this is why I was asking earlier about opt-in or opt-out to DMA, because in this model, you have to explicitly opt-in by Bob says, well, hang on, I want to bust out of WhatsApp, I want to talk to people on Matrix or wherever, I'm going to install a client-side bridge to do so. Likewise, you could have Charlie on the other side, who happens to be on a different client. It could be Matrix or whatever, and they want to talk to people on WhatsApp, or they want to connect their WhatsApp account into Matrix. But they don't want to install WhatsApp itself from Meta. So they would, again, install a bridging app. Now, the problem with this is that whilst it's the simplest thing for the gatekeeper, in that they can just expose their existing server-side API to allow the requesting party to develop a bridge. The minus side is that the red here shows basically where the traffic is going, that data from WhatsApp is going to go off to WhatsApp, it's then going to bounce back to the bridge running on the client, it's then going to go off to some kind of Matrix or Mimi server, whatever it is, and then talk to other people on the big open network via bridging as well. So it's a little bit complicated and clunky, although it does work, and I'm going to try to show a demo of it working for Railses in a minute. In terms of the users, it means that they have to explicitly opt in if they want to bust out of the gatekeeper by installing the bridging app. It's nice, however, that the bridge app could be written by anybody. So you don't have to install a binary blob or a proprietary thing from a gatekeeper. Instead, there can be an entire ecosystem of third parties who are going and implementing these bridges to basically bridge between the proprietary API that the gatekeeper already has and a more interoperable open network in the middle. So then, what about a different scenario? What if we were doing client-side bridging? So we've introduced a new user here called Iona. She's on iMessage. And what we do here is to take the interface where the bridging app was previously talking to the server, and instead we still install a bridging app, but this time it just talks locally straight to the client. So this isn't that far-fetched in that Apple already provides an API called Messages, I believe, that allows apps on iOS to go and send and or certainly send messages via iMessage. I don't think it allows you to receive them yet. So if you extended that API to allow a bridge app to go and start sending and receiving iMessage, then that bridge app can go and participate in the Mimi, Matrix, XMPP, whatever network, whilst also locally going and interoperating with that local iMessage client and all of the funky identity that already exists talking through to the iMessage bubble. So again, this is letting Iona basically bust out of iMessage and participate in the wider network. The disadvantage here is that the device operating system probably has to provide an API that you can hook into for implementing this sort of bridge. The gatekeeper gets to keep their app as it is, but they do need to work again with this new API to expose the client-side API through to it. Then as the third example, the Polyglot app. This is going to use Fred as a hypothetical Facebook messenger. Let's assume that Facebook has added in an open standard alongside the existing one. Now, this is obviously more work for the gatekeeper here. They're going to have to actually go and effectively take that bridge, implement it themselves, and move it into their app itself. It's a bit like a multi-headed messenger, which might make people think of Trillion or Pigeon or some other old school multi-head messenger. What I would ask you to think of instead is iMessage, because iMessage today is a multi-head messenger. It talks to SMS and it talks to iMessage, and it goes and copies data back and forth between the two. I'm sure people recently on Macs will have noticed that if they receive an SMS on their phone, it suddenly pops up in the Messages app on their MacBook Pro. So it is literally doing, well, in that instance, it's doing client-side bridging. It's acting in the second scenario, but it's also acting in a polyglot thing that you get your green or blue bubbles depending on what stack it's using. So we're effectively proposing adding a third-party stack alongside the legacy one. And then finally, and no, that's obviously a whole bunch of work for the gatekeeper to be doing. And then finally, the biggest one, the kind of logical conclusion, if you have Gemma as a hypothetical Google Chat user, let's assume that Google Chat decides to just switch over to the DMA native network, whether it's Matrix or Mimi or combination of the two, and just switches over entirely. That is kind of the extreme scenario. So looking at the end result, we'll publish the slide so you don't need to look at this in detail, but there you have the 4 different scenarios in different colors showing various different people in different incarnations talking together interoperably. The pros and cons here, just to summarize, are that on the client-side bridging, minimal effort from the gatekeeper. Bridges can be supplied by everybody, but the traffic bounces around all over the place. 3 client-to-server traversals and back again, and also the gatekeeper users have to opt in. Then for client-side bridging using client-side APIs, needs a bit more work to define what that client-side API is, but then the traffic only does 1 traversal between the client and the server. Then for the Polyglot app, the gatekeeper users can just automatically talk to the receiving parties without installing a separate app. No bridges, no more opting in. The bridge is effectively within the gatekeeper app, but the gatekeeper is going to have to add it alongside their existing stack. And then finally, the consolidated approach, as Alyssa called it, where the gatekeeper is switched to an open protocol, and the gatekeeper users can automatically talk to all the receiving requesting parties who implement the open protocol. The only con on this, I guess, is that the gatekeeper's investment in the existing stack is lost. But sometimes a gatekeeper might consciously choose to do that. For instance, Reddit has adopted Matrix as a standards-based DMA-compatible protocol rather than maintaining their legacy chat network. So I'm not going to talk about user identity, but what I am going to do is try to do a live demo of this working in practice, which is probably going to go horribly wrong because we don't have the DMA yet. And so in order to do the demo, what we've done is to implement here, and apparently I can't screen share on a screen share of a screen share. Oh, no. Yes, I can. Oh, that was awkward. All right. So if you look at my Android phone here, you can see we've got WhatsApp here and Google Chat here, and we're going to try to bridge them together. In fact, I've got a little diagram of this here. So let me just show you this. So concretely speaking, we're running a bridge app on Alice's side, a bridge app on Bob's side, and then we're going to try to have WhatsApp talking via the WhatsApp servers, via the bridge, over to Matrix again, to another bridge app that goes to the Google Chat servers, that goes to Bob operating on Google Chat. This is why we say that client-side bridging has got a lot of arrows in it. That said, it will hopefully work. So if you actually look at these bridge apps that are installed, they're sitting there, very basic user interface saying it's the WhatsApp DMA bridge. Looks like everything's being bridged between WhatsApp and Matrix. And likewise, I look at the Google Chat one, and it's saying, looks like everything's set, and they're being bridged back and forth. Now, if I actually go into WhatsApp here to DMA Demo 2, and we pray to the demo gods, I say, hello, everyone, if I could type. And this is just on a normal WhatsApp account. And if I peg back into Google Chat here, you will see Matthew Hodgson saying, hello, everybody. So there you have it, a real-life client-side bridging-based demo. Going from WhatsApp through to Google Chat. To prove that it's going via Matrix in the middle, what I'm going to do is to hop over to a Matrix client, which I have here, and you can see that there is this kind of intermediary user called demo that is actually bridging things back and forth here. And if I look at the source of this, you can see the plain text is a little Matrix payload saying, hello, everybody, but critically, the original event source is encrypted in my dangerousdemos.net domain. So this was entirely end-to-end encrypted, with the encryption being re-encrypted on the handset where it's already encrypted. So we're not undermining end-to-end encryption. We're not doing server-side bridging, which we just dismissed entirely as an option. We go and do the bridging client-side. And just to demonstrate it, hopefully happening the other direction too, I can try to get my Android phone to rotate and say hi from Google Chat. And on the matrix side here, hopefully, wherever it's gone, there we go. You can see hi from Google Chat. And over on my personal WhatsApp account, you can see, because I'm also lurking in this room. I should have said this is group, by the way. This isn't one-to-one. This is a multi-user chat. Because I agree completely with Alyssa that everything should be group and that one-on-one is just a subset of this. And if I flip over to my Google Chat demo, wherever the hell Google Chat has gone on my phone, there it is, sorry, WhatsApp, then you can see the -GC message there on WhatsApp too. And there's just two very quick final things to add to this. That if I take my normal WhatsApp account and say, hey, from my normal WhatsApp account, we've got the problem that my normal WhatsApp account doesn't actually exist in Google yet. And pre-DMA, there is no way to have this concept of remote users. So instead, we have this horrible thing here that says a horrible WhatsApp user says, hey, from my normal WhatsApp account. And if I say, I know, hey, from my normal Google Chat account here, because again, I'm logged in as my normal user rather than a demo user. I go back to WhatsApp. You can see that Matthew Voxu, which is the name of that particular contact, comes in bridged like this. Now, this is purely because you don't have a way to create remote users today pre-DMA. That's the only other thing that the gatekeeper needs to do. That WhatsApp needs to know that alien users exist, and likewise, Google needs to know that alien users exist. But if you had that, you basically got the working components for the simplest possible implementation right there.
Thank you, Matthew, for providing us with the solution, and now maybe a solution. Now maybe giving the floor to Stephen to tell us how he feels about this.
You're going to do it.
Thank you.
Me.
I won't be nearly as brave as Matthew to do a live demo, but we are today to listen to perspectives like Matthew's and others in the panel. We're quite new to this, obviously, like many of us here today. So this is, very stimulating debate for us too. The WhatsApp team has been spending a lot of time thinking about how to build an interoperable solution, which focuses on users and aligns with WhatsApp's core principles. And that's around ensuring simple, reliable messaging for the over 2 billion people who use WhatsApp daily. And we see these principles are also shared in the DMA itself. People have talked about this already in many ways. There's key safeguards in the DMA around ensuring that that interoperable services prioritize user choice, security, safety, and privacy. This panel, I'll focus mostly on security and end-to-end encryption, and then obviously in panel 3, we'll touch on some of the other considerations. And we think the DMA is a reflection of the vital importance that users place today on the security and privacy of their personal communications. For today's purposes, and like many of us today, I'll be focusing my comments mostly on WhatsApp. Obviously, I should say at the outset, as I think Rita did in her opening remarks, that the process is still ongoing. There are no obviously findings with gatekeeper designations or core platform service listings, so we're talking in principle at this point. As I'm sure many know, WhatsApp is a global messaging service used by over 2 billion people globally on a daily basis, delivering more than 100 billion messages and 1 billion calls each day. We do this by protecting all personal calls and messages with end-to-end encryption, which has been fully implemented on WhatsApp via the Signal protocol since 2016. All of us share a lot of our most sensitive information digitally now, whether that's sensitive medical records, confidential bank details, or even everyday family photos. And meanwhile, as you know, bad actors, such as criminals and hostile states, are all trying to break into those personal communications. And end-to-end encryption protects us from those online threats, and we must not take it for granted, as the DMA doesn't. And security and end-to-end encryption are at the heart of WhatsApp. And if you've used WhatsApp, you'll notice that at the top of every personal message thread, there's the following promise to users. It reads, "Messages and calls are end-to-end encrypted. No one outside of this chat, not even WhatsApp, can read or listen to them." In order to live up to that promise,
every WhatsApp message is protected by the Signal end-to-end encryption protocol. And that secures messages before they leave your device and guarantees that data is fully encrypted at all times and can only be seen by the sender and the intended recipient. Again, not to labor the point, no one else, not WhatsApp nor Meta, can access these messages. We therefore welcome that the final text of the DMA reflects these core principles that are so important to our users, and indeed for many other users in the wider messaging ecosystem. Paramount among them is that the gatekeepers shall preserve the same level of security, including end-to-end encryption, that they currently provide to their users. Interoperating with third parties, however, presents substantial challenges for WhatsApp's ability to guarantee the security of all endpoints in the messaging chain. In short, once a message has been sent from a user on WhatsApp to a third party, that third-party service could, in principle, do whatever they like with it, whether by accident through things like security vulnerabilities or intentionally through design. Sharing private messages with third parties, therefore, inherently makes it much harder for WhatsApp to stand behind its core promise to users at the start of every chat that their messages are and will stay protected by end-to-end encryption, and that no one else other than the sender and recipient can access them. And security experts have repeatedly proven that when you weaken one part of an encrypted system, you weaken it for everyone, everywhere. An interoperable network is therefore only as strong as its weakest link. And this risks undermining the trust users have in end-to-end encryption in general, and WhatsApp specifically, to protect their most private communications. You'll understand, therefore, that the core principle in the DMA to preserve the same level of security and end-to-end encryption for interoperable services as we do for WhatsApp users today poses a particular challenge. So while we very much welcome and support the DMA objective to preserve that level of security and end-to-end encryption, this is a core conceptual and practical tension that we, and I'm sure many others, have been grappling with when we're thinking about potential solutions. So how is WhatsApp currently thinking about this? As I said at the beginning, we've been carefully considering how to build a solution that is consistent with the principles in the DMA around honoring user choice, security, and privacy. In order to mitigate some of these risks, we think that WhatsApp and third parties can work together to meet the DMA's core principles and mitigate those risks as much as possible. First, we think the interoperable services should indeed rely on the same tried and tested open source Signal protocol that WhatsApp has deployed since 2016, and which today protects the private communications of over 2 billion users daily. Of course, it's not just WhatsApp that relies on Signal, as we know. Lots of other messaging services do, such as Signal itself, obviously, Google's RCS platform, and indeed Skype. And in many ways, it has become the de facto global standard for modern encrypted messaging. Second, we think it's important that the interoperable services retain a certain number of important additional security features. It's not just about encryption, obviously. We need the ability to identify and verify exactly who's part of conversations in order to avoid so-called person-in-the-middle attacks. We need security notifications when new users are added into a group or identities of existing users are changed. We also should look to have deletion and rotation of encryption keys in a timely manner. Third, we need all parties to ensure to carry out regular app upgrades so that everyone on the network is using the latest and most secure version. Finally, and I'll talk about this a bit more detail in the next panel, we also think it's important as part of any solution that users are made aware of and understand the key differences between the security guarantees provided by a first-party and third-party interoperable messaging experience. As I said at the beginning, we are keen to hear how others have been thinking about these problems, including the very interesting views of the panelists just now. And we know that independent experts from Berwick, Benetza, QUIC, and others have all published studies looking at this very issue. And each concludes, as we do, that alignment around existing standards or protocols will be necessary, although not on their own sufficient, in order to maximize the level of security between interoperable services. I've already set out what we see as the key benefits of the Signal protocol, which, as I said, has been tried and tested at scale for many, many years. Each alternative solution obviously comes with its own set of trade-offs. Established standards we've heard a lot about today, and they can benefit from participation and buy-in from a wide range of stakeholders, but as we've seen, can take many years to agree. Standards also risk becoming frozen in a moment in time, potentially unable to deal with the dynamic requirements of the DMA as it is today, but also as it might evolve over time. We've seen this play out with SMS and email, which, being based on open standards, have remained largely unchanged for decades without any significant new functionality. Contrast that to messaging, which benefits obviously from rapid and constant innovation. Panelists have spoken about MLS, and Meta has worked closely with the IETF for many years on MLS. 2 of the 6 listed authors of the MLS protocol are from Meta. And However, unlike Signal protocol, as far as we're aware, MLS remains largely untested in practice. It has seen very limited production deployments and is yet to be used at scale to protect private personal communications. Similarly, the MIMI group at the ITF was only established in September last year. It set itself some very ambitious timescales, but it's difficult to see how it could be made operational to meet the DMA's timelines, which likely requires gatekeepers that are ready to provide interoperability by Q1 next year, just 12 months from now. Server-side bridging solution, as Matthew said, is another option that has been raised, but I think largely dismissed, as they inherently involve a third party having to decrypt and re-encrypt content, breaking the fundamental promise of end-to-end encryption that only the sender and recipient have access to messages. Client-side bridging is an interesting solution, but again, not tried and tested at scale as far as we're aware, at least not for consumer-facing services. It also raises potential practical issues, such as regular upgrades and swift patching of vulnerabilities, as well as potentially pushing up against limits of mobile OS. Finally, as noted by Beric and others, bridging solutions potentially raise privacy considerations as users become unaware of their role in the ecosystem. More generally, for any potential alternative approach, I think it's also worth recalling how the DMA obligation itself is structured. For one thing, we need to recognize that it's the gatekeeper that bears the sole legal responsibility for providing interoperability with their services under the DMA. This necessarily impacts the range of options available. Let's not also forget that time is very much of the essence, unfortunately. The DMA anticipates that gatekeepers will be ready to implement interop in Q1 next year, as I say, just 12 months from now. So I think it is important that we keep these practical requirements in mind as we discuss potential options. To conclude, these are some of our early thoughts on potential solutions to meet the challenges raised in Article 7 when it comes to preserving the level of security for users. Unlike many others here today, I'm a simple lawyer, not an engineer, but having now spent a lot of time with the teams at WhatsApp working on this, it's clear this won't be an easy process, and I think the panelists have outlined some of the challenges we'll face in this. It's something like this has never been done before at the scale of WhatsApp or indeed other potential gatekeepers. And as the DMA recognizes, and as I've outlined today, interoperability does raise some key challenges and trade-offs, not least in terms of preservation of security, end-to-end encryption, and on timing, as I've mentioned. However, I hope I've made it clear that WhatsApp is committed to and has already started to address those challenges around how to build an interoperable solution that meets the core requirements of the DMA, including the key safeguards I've outlined to protect the security of EU users. Thank you.
Thank you, Stephen, and thank you all for very, very interesting interventions in the panel. I'm sure there are numerous questions both inside the room but also online, so maybe we start with the room, take a few questions. First, we give the floor to the panelists, but please short intervention so that we can benefit from others as well. Matthew, please.
Okay. Sorry, just very quickly wanted to say on Stephen's point then about client-side bridging not being proven at scale. Obviously, my demo isn't there, but iMessage is literally doing it today between the SMS and the iMessage stuff and has been for a few years. So it's a really concrete example of how they're basically linking those ecosystems together client-side.
Okay, please.
Question for Stephen. Facebook or Meta has Meta has two other instant messaging platforms, Instagram and Facebook. Those are not primarily end-to-end encrypted, though some people have secret chats. What is Meta thinking about those two platforms?
I think, as I said at the outset, the discussion with the Commission, I think, is ongoing around exactly the designation of not only the gatekeeper services, but then what core platform services sit underneath that gatekeeper designation. So I'm here, certainly today, I think WhatsApp presents as sort of a paradigm of the challenges we face, not least on the encryption side. So I can't say more at this point around how that core platform service process will work its way out, but I think that's an ongoing discussion.
Sorry, there was someone. Yeah, please.
I just wanted to ask Paul about the first step in his diagram, which was the a connection to some service to find out your what service the other user is using. I'm kind of the belief that that's an optional thing, that if I already know what the service is that I want to connect to, I should just be able to connect to the user at that service. My main concern, though, my question is, how would you solve the privacy implications? I mean, there are a number of privacy implications.
Yeah, sorry, I took away your word already by clicking my button. Yeah, I do agree. That was also not the focus of our panel here, and I haven't found anything in the DMA that says how that actually would work. And which brings me actually to we wrote a paper that isn't public yet, but will be public hopefully within the next month, in which we also talk about how to make sure that this step could be privacy preserving if users want to be detected via such a third-party service. There are multiple different cryptographic ways that could achieve that, still practically deployable. But I do agree with you that, of course, users can or should be able to opt out of that discovery service. Yeah. And I also do agree with the question that was raised earlier today, that migrating from one service to another is something that, as far as I know, is not captured by the DMA, but a very central and interesting, technically challenging question.
Yeah, maybe we're going to the online community now, which from the number of questions we received on Slido suggests that there was also a lot of interest there, and the panel's contribution were received with great interest. I start perhaps with a preliminary question, and I take the liberty to group two questions together. The preliminary question is whether the meaning of security and end-to-end encryption is the same or not, and whether we shouldn't address that question first, and then maybe in the context of end-to-end encryption, specifically to Matthew, a question to whether you could elaborate a bit more on end-to-end encryption and client-side bridging.
I would say that end-to-end encryption is a mechanism and not a property, and I would actually criticize the DMA writers that you should not fix a technique, but rather a property, and confidentiality is the property, and the level of security is probably more than only confidentiality. But I would say that everybody who understands the DMA would interpret the end-to-end encryption as end-to-end confidentiality, and the level of security that is everything captured around confidentiality, and that would be my answer to that. So basically it means confidentiality is the minimum, even if, for example, Telegram doesn't offer confidentiality for group messages. It would be required, as far as I understand, for interoperable communication. But everything that is provided for internal communication should be provided too, which goes beyond pure confidentiality.
In terms of end-to-end encryption in the context of client-side bridging, apologies, I mangled this by rushing for it earlier. I was feeling bad about going late on time. But the idea is that your client, your phone, already sees your unencrypted messages. So in a server-side bridging context, whatever thing sits in the cloud converting your WhatsApp messages to your matrix or your iMessage services messages would obviously be a massive vulnerability. We have to do everything we can to prevent server-side bridging happening. However, by bridging client-side, your phone already sees those messages. So yes, you're going and taking the encrypted payloads from WhatsApp, unencrypting them in a WhatsApp client of some kind on your phone, and then re-encrypting them for a DMA sort of interoperable wider network. But because that re-encryption happens in the place where the user can see the unencrypted messages anyway, you're not actually violating the end-to-end confidentiality property of the system. It's a little bit of a strange thing to think about, but that was basically the demo that I was trying to present earlier.
If I may. I think actually this is a good demonstration of the difference Paul was just drawing between security, which is a broader concept, and encryption, which is a narrower technical concept, in that, that, as you say, this does provide a level of end-to-end encryption, but what it does is breaks end-to-end authentication in a way that is confusing to the user. and which is not saying it's not a possible approach, but that security involves a number of different properties, and in an ideal world you'd have like a broader set of properties than encryption, which I think actually goes to a number of architectural questions, which I think you were also suggesting, about like how does the system integrate as a whole, and what is the when higher end properties look like.
And just to add, I completely agree. I guess that I think the DMA makes it clear the distinction in a sense with end-to-end encryption being a subset, including, so it's protect the security, including end-to-end encryption where applicable. So it's a wider than just that element.
Thank you. Okay, let's go back to the room, maybe. Vittorio.
Hi, Vittorio Bertola from OpenXchange. So I have a question for all panelists, but first let me make a very brief point on email, since it was mentioned, I mean, the lack of innovation of email. And I think this is important to our discussion, because email is not changing a lot because it has become basically a basic utility, like water, electricity, and people expect it to work exactly like that, and they only notice it when it doesn't work, and they really want it to continue working exactly the same way because they've been using the same interface for 25 years, and if you move the icon from here to there, they just get crazy. So I don't know if instant messaging is going on the same trajectory. It could be as well. I mean, once a service becomes so diffused in the mass and so used, it might be that it becomes just a basic service, and you continue innovating on top, on side, adding stuff, changing the interface, the colors, the way you present the messages. But the basic communication layer will become accepted by everyone. So I don't think this is actually a problem. But on top of this, my question to the panelists is, I mean, we've been discussing the end-to-end encryption issue. I think we can discard the server-side bridging because we discovered that you actually have to break it, if I'm not wrong. The client-side bridging was, it was an interesting presentation in the face of all difficulties, but I do agree that it might be brittle. And so I'm wondering if there is anyone on the panel that does not think that the only really good and best solution, if we could agree with that, if we could all get to it, would be having this single protocol which would ensure basic end-to-end encryption and solve all of the authentication issues and work everything out in a smooth way for everyone.
So, I mean, obviously, from my perspective, the best outcome here is that people are on a consistent protocol, which is open and one that can evolve rapidly as new features emerge. However, I'm a pragmatist at heart. If I went to Stephen and said, hey, Meta, you got to throw away WhatsApp and replace it with Matrix tomorrow, I wouldn't be surprised if he was a little unhappy and dubious about that, reasonably. So that's why we're proposing client-side bridging as baby steps, really easy thing that just works. And in terms of fragility, I think we've got a chicken and egg problem here. Everybody says, oh, client-side bridging is hard because gatekeepers don't have public APIs and they make it hard. Well, the whole point of DMA is to fix that. So we can't use the data points of the past to try to predict the future when the whole point of the exercise is to make things like client-side bridging so much easier. So in terms of the other implication that standards can't evolve, it's true that the second you put standardization in there, things slow down. However, if you layer things intelligently and you get like stable base layers like IP and TCP and HTTP, and if you get the balance right, then it allows people to go crazy and innovate on top. And we consciously try to do that at Matrix by going and building crazy things like a open interoperable metaverse system called Third Room on top of Matrix to spell out that it's not just chat, it's not just VoIP, but you can do crazy next generation things as long as it's built on underlying foundational layers which are mature. So you can have your cake and eat it, basically.
Yeah, just possible to keep these things on. Yeah, I mean, one thing is to say, slow down compared to what? Like, there's people probably in this room who have been working on trying to get interoperable messaging in this industry for more than 20 years. So this idea that like, oh no, if we try to consolidate around something that's uniform across the industry, it's going to take like another extra year. My God, what will we do, right? I mean, it's not really compelling. And I definitely agree. Q1 of 2024 is very soon. Q1 of 2026 is like not that soon, and I think there's a lot of good work that can be done if we come together around a standardized solution. But I would also say that to me, what's an open standard is something that's very specific. Like it's actually open. There's not a single vendor that has change control over what either the specification, the protocol, or the single library looks like. There's nobody who can unilaterally impose licensing fees based on the offering of the library. So even within the realm of what I was calling consolidated solution, there's still a lot of variation out there. And I think we need to be very cognizant of who is able to influence the process of what gets standardized and who has access to the standardized solution in the end. And some of those things can be done in a very open way, like we do in the IETF, but that's not necessarily what will happen. So I think we just need to appreciate that there's variety out there.
I mean, I think you knew the answer to this question, Vittorio. I think it is clear that from a just a technical perspective and deployment perspective, it would be better if, as much as possible, the system were common, because otherwise it's still an enormous amount of application. And as I was sort of trying to allude to, these software stacks are very complicated, and so having a copy of everybody's software stack in my system is very undesirable. And it's not just the crypto; it's the media and everything like that. With that said, I think and I think Matthew has a nice diagram of the progression. I think it's clear that the Polyglot app is less good than the common standard, but better than the others. But I think the point I would like to make is that it's not an all or nothing question, which I think Liz was kind of trying to say. That is possible to have some pieces of the system standardized and some pieces of the system proprietary, and as different pieces of the standards mature, then it's possible for people to adopt more and more of the standardized components and still innovate in other ways. And I think that's the future I hope we're looking at, is one in which the pieces that are mature enough to be standardized are the ones that are common, and the ones that are still moving are a place for evolution, and we have a set of systems that are extensible enough and flexible enough that they can accommodate that kind of innovation while also accommodate commonality where it's possible.
Absolutely.
And maybe just to comment on innovation specifically, because I think that was part of the debate in the DMA legislative phase, and specifically, as I understand it, at least the concept of basic functionalities was designed in part to address concerns that this process would lead down a road of sort of lowest common multiple and everybody just using very static, very similar messaging service. And I can't imagine that's what many in this room or anywhere else would value. So I think we do have to be alive to the fact that the DMA in its final form reflects that trade-off between trying to cohere around a common set of basic functionalities, but then enable and allow for innovation above and beyond that. I'll leave it there for now.
Yeah, to let everybody speak about that question, I also have one small comment. I think standardization sometimes leads to big commitments to bad legacy. We've seen that for TLS 1.3. Probably people who know about that protocol was changed to just look like its predecessor, just because there were middle boxes who blocked everything that looks different from what the old protocol looks like. That's terrible, and we should make sure that if a standardization approach is followed, such bad legacy commitments are avoided. Another problem of standardization, especially in the ETSI here, was seen in the eTLS protocol, where security features of the new TLS protocol were removed just because there were enough people who voted for weakening the protocol. Those two things, I think, must made sure in a standardization approach, and I'm sure that communicating and unifying several things in that protocol makes sense. But what I also wanted to emphasize with my talk was that either way, both with the gatekeepers protocols, but also with a standardized approach, we can achieve strong security guarantees. And I think we shouldn't rush a standard only for making sure that the first DMA implementation already follows a standard. I think that's, at least from the security perspective and from the long-term perspective, something important.
Sorry, I just want to bring in a question online that relates to this and maybe brings the security discussion back to the text of Article 7. And the question is, which measures by gatekeepers to preserve security, integrity, and privacy can be considered as, in speech marks, duly justified and strictly necessary and proportionate? So how do we bring it back to the legal text that we have?
I guess as the lawyer on the panel, maybe I should take that one on.
I don't know what any of those words mean, so yeah.
Very happy to defer to Commission colleagues also. But I guess we've been trying to think of it in maybe two contexts. There's obviously Article 7.3, and we're not going to get too heavy into the article references, but there it's a mandatory provision, right? You shall, the interoperable services shall preserve the same level of security and encryption. I think that's fairly clear, and that's obviously the topic of a lot of what we're discussing here. How can you do that credibly, reliably in an interoperable world? And we've all talked about the potential trade-offs there. And then I think the final provision around the gatekeeper not being prevented from putting in place additional measures to preserve, I think it's security, integrity, and privacy. That's in our world more permissive in a sense. Like it's what are the ways in which the gatekeeper needs to think about. I think we'll come to this in panel 3 about ensuring it's not a service that's bugged or flooded with spam. What are the ways in which we can minimize the privacy concerns? There, it's more of a permissive and probably more of a balancing act that I think has to be undertaken in terms of proportionality and what's necessary, what's the least burdensome way, are there other ways that can be done, and clearly that'll be, I'm sure, a key part of the Commission's role in assessing the reference offer and the practices of gatekeepers and third parties when we see this live.
So one thing I would like to add here is it's not necessarily, I don't disagree with anything you just said, but this is a sort of very, I would say, let's keep things okay kind of view. But I think it's also important to recognize this is an opportunity to improve the security properties of these systems. In some cases, security property systems are not very good, and even in the cases where they are using state-of-the-art protocols, they often do not provide the integrity and user identity guarantees that one might prefer, and because they're closed solutions that do not provide open transparency around the identity. And so this is an opportunity in a variety of ways, which I don't think is worth getting into here, to actually improve the state-of-the-art, not just to maintain it.
Maybe to go back to the room, because I saw a couple of you ask. Alan, do you still want to ask a question? Because I saw you before. It's irrelevant. Okay, so maybe, and then we go to Jan. Sorry, I haven't seen it.
Thank you. Question to Matthew. These microphones. Matthew, can you tell us how many people have worked on the demo that you showed us and how much time it took you?
Yep, thanks, Jan. I completely stole credit for a demo I had no input in whatsoever there. So that was actually one guy working for about 3-4 weeks on it. We cheated by building on top of the WhatsApp bridge, the Beeper release. We're using Talir's bridge, and there we actually wrote our own Hangouts or Google Chat-based one specifically for the demo, because ironically the previous ones had broken because the goalposts had suddenly changed mysteriously under us from the gatekeeper. So in terms of the fragility of the client-side bridging, I mean, it goes to show that it's not actually that much work necessarily to put this together, even if you're using adversarial bridging. And imagine how easy it would be if there was actually a stable, well-documented open API.
Thank you. I'm asking this question because Stephen has made the argument again, which I've heard a lot of times in the past years, that this is too hard and there isn't enough time for the gatekeepers to adapt. Now, I don't want to compare a simple demo with rolling out a system for billions of people. Of course, it's not the same thing. It doesn't need the same effort. But Meta has literally 76,000 employees and makes $23 billion of net income every year. So I'd be surprised if they can't get something useful, usable out there. Just to recall, when WhatsApp implemented the Signal protocol to roll out encryption to billions of people, that took a little longer than a year from what I could see from press records.
Not sure I need to respond to that. I think it's what they call in the business a jury point, but we'll take it. No, fair comment. No, I think the point very much is, I think that was very clear and interesting demo, and I think as I might clear, WhatsApp internally is working through a lot of these issues, I would say at scale and facing many of the challenges that a platform that serves 2 billion daily users faces. Not to say that these aren't interesting perspectives, it's just I wouldn't say it's apples and apples. So I think we just need to bear that in mind as well. Please.
Hi, my name is Rafael Robert, and I'm one of the authors of the MLS protocol. And so it's been mentioned a number of times now, and there were 2 things that were said that I wanted to go back to. Maybe for perspective, it took about 5 years to get to the point where we are now, which is very close to the IRC, I want to say. Just a bit of bureaucracy left on the IETF side of things. But yeah, it took those 5 years because it was the first time that an end-to-end encrypted protocol that is as complex as MLS was standardized at a body like IETF. So that was essentially new for everybody. Yeah, since it is a proposed standard, it's constantly being compared to email, which is literally the worst comparison you can make, because the email, as we all know, has never meaningfully evolved as such. And so that was a very good point earlier on, maybe because people expect it to not evolve. But that's not true for other protocols. So TLS, for example, has seen a number of iterations. So a few points of criticism earlier on some aspects of TLS, but keep in mind that it's a lot harder to upgrade TLS than it is to upgrade MLS potentially in the future, simply because there are hundreds of TLS implementations. There are different servers, different clients. All of that needs to be extremely compatible, and yet it still works. And the other thing is that in terms of quality of protocols we can produce these days, again, I'm going to mention TLS 1.3 here. We know how to build better quality protocols these days than, say, 20 years ago or only just 10 years ago. We have academic analysis that is part of the design process. We have formal verification, which gives us a level of quality that we didn't have before, and a much higher confidence that we don't need to urgently fix stuff, most likely. Yeah, and the final point is about the fact that MLS is not really deployed yet. That's true, because we are only just finishing it now, and that's not terribly exciting to deploy something that is still a moving target. So Cisco was very bold, Elisa said that earlier, to actually make a large-scale deployment. That was fantastic. Thank you for doing that. And so I know that a number of other stakeholders are trialing MLS, and if it all works well, want to deploy it.
Yeah, I was just going to say that we have deployed MLS for end-to-end encrypted meetings, meetings up to 1,000 participants per meeting. So we think that's, that's pretty good scale for a meetings product. Serves like most of our customer base at that size. So.
Can you say about how big that is? No?
No.
Okay. That's for video as well, right?
Yep. Yep. Voice and video.
Oh, sorry. Yeah. Yes, I think one thing that I think maybe getting a tiny bit lost here is there is a connection between the security for the instant messaging and security for the media, and they have to be glued together. And so the problems of having large-scale end-to-end encrypted video conferencing are not entirely solved. But do depend on having like appropriate cryptographic protocols underneath that allow you to do that. And so one of the things, and this is as Raphael and Rowan and Alan know, was one of the design criteria for MLS was to make it suitable for that application, because exactly for the reasons I was indicating.
If I can just jump in, there's something that really scares me here, which is the fixation on the specific encryption protocol being used. Yeah. I mean, Stephen saying, look, we want to use the double ratchet or the signal protocol because it's well proven, is fair enough. No, the MLS guys saying, hey, you should use MLS because it's algorithmically better than the double ratchet. Both of them feel to me to be the wrong angle, and that what we need is agility in whatever common standard emerges out of this. On the Matrix side, we started off with pure Signal protocol, like Signal users. Then we evolved it to a thing called Megom, which is quite similar to what WhatsApp uses. Nowadays, we're implementing MLS. But in terms of needing agility to switch to post-quantum technologies, or if it just turns out MLS has got a huge issue in its design flaw, the ability to have the agility for the protocol to evolve is absolutely critical. And on the Matrix side, it's something that we got wrong for the first 3 or 4 years until we found we had a big gaping error whilst we were still in beta, and then implemented ratcheting at the protocol level, not the cryptographic level, into all aspects of the thing, so you can basically upgrade itself from under itself whilst it's running. So hopefully, 100 years from now, something like Matrix will still be running around, still called Matrix, and all of the component parts, like the proverbial ship of Theseus, will have been swapped out with better implementations, better algorithms, etc. But you have to have the agility in mind from the outset, because it would be a disaster if we say, well, DMA stuff has to talk double ratchet or Signal protocol, or if it has to talk MLS.
If I can just maybe quickly comment on that. So that's true, the Signal protocol and MLS are both two protocols that solve end-to-end encryption. But the motivation with which MLS was designed is a completely different one. At the time, literally everybody was invited around the table. And Stefan just said it. There were 2 folks from Meta or Facebook at the time who joined in. So, it was a standardization process. So it's literally one way of achieving something that has a similar quality than the Signal protocol, yet taking into account all the needs of all the vendors. So it's more about the process rather than about the specific technical outcome. Right,
but I still think you still need agility effectively in that. I mean, to just put a concrete example on it very briefly, if, say, we decided for some version of that the Signal protocol is the way to go. I mean, I think WhatsApp caps out at 1,024 users per group at the moment. And I don't know, on Matrix today, we already have groups with 10, 20,000 people or whatever in them. If one has basically standardized on architecture that has scalability limits on it, then it's just going to break it for everybody else. So I'm not picking on MLS at all. I'm just trying to point out that any decision on any long-term commitment there could be an error, and it's instead the meta problem that needs to be solved, so to speak.
Yeah. Let me try to bring this back to a point. Let me try to bring this back to a point of consensus, and maybe you can as well. Which is, I think, it is clear that all these systems need to be able to evolve, and it is never the case that anything is done. And so, as I was saying earlier, we need to standardize. We need to, it's not standardized, that's the wrong answer, necessarily. But like the ideal situation would be to have the pieces that we all agree on and they're good and well understood be the ones people use, and that leaves room for innovation outside of those and for evolution of the systems as we discover they need to evolve. I'm not sure you're going to disagree with that.
No, I don't disagree at all.
Yeah, online. And before I take the next set of questions online from the online community, I just wanted to say that there are a lot of questions that we can't all answer today, and some very good ones on video conferencing as well. But given the time constraints we are under today, I suggest we're focusing on the messaging one, given that this is the obligation that kicks in first. I wanted to take 2 questions to do with cryptographic keys. And maybe then they can be answered in a pack together. The first one is, when data is being transferred between providers, how will Article 7 ensure that cryptographic keys are never sent over the network? And the second one related to this is, and then specifically with relation to the reference offer, how does the reference offer specify end-to-end encryption keys discovery across services? And for example, how are keys discovered securely cross-provider?
I would say that the requirements, either in normal cryptographic protocols, in the cryptographic literature, also in the DMA, are specified for the functionality that we want. And the functionality is at the end that Alice can communicate with Bob interoperably. And so it doesn't matter too much how we specify what happens between two providers, or I forget the details of the second question, but basically the requirements for the functionality imply requirements for all the technical necessities that take place in the meantime. For example, if we want to have privacy for the communication, then that means we also want privacy for key distribution. If we want to have confidentiality for the messages, then that means that the keys with which we encrypt the messages should not be published or revealed between two providers. Basically, the confidentiality requirement for the messages implies that the keys are also protected between the providers.
Yeah, I agree with that. I think that, to circle back to that second question, I mean, the reference offer will have to specify what end-to-end key exchange protocol is required to implement to talk to that gatekeeper. And I think that the question, the last bit of that question about how one discovers the identities and keys of people is really like a big TBD, as Paul was indicating in his conversation, and partly is going to be something that has to be figured out. And in particular, whether or not that's something that is per gatekeeper or something that is globally consistent and understood. And I think that's going to be something that's going to have to be figured out both between the gatekeepers and between the regulators and the gatekeepers.
If no one else wants to reply, maybe Alan, I know.
Yeah, just to reflect on a previous discussion, I think super interesting one part that Matthew said with agility, fully agree with it, but also as Eric pointed out, one thing doesn't exclude the other. If we see, like we could argue about it, but WebRTC was amazing success, 6 billion people using it, how we nailed it, Eric, ILBC, Opus components that were developed, it was added more stuff around it, and then agility was everything what came after. This is, I think, something what we can learn from the past, and then in a similar way make this. And also coming back to what Alisa said, post-quantum, because what we are building now should last for another 10 years at least. If we now build a solution that doesn't include anything related to post-quantum, there's not going to be any backwards compatibility, and there's going to be a nightmare.
I just want to say that. Oh, thank you. I just want to say that although probably WebRTC is a success story, it will be important that the complexity of a DMA protocol will not be as high as WebRTC. Because it's very important that the non-gatekeepers have also the ability to implement that stuff. And I think we've seen, that's something that I've seen in the discussion also a couple of times, the interoperability between Microsoft Word and OpenOffice or LibreOffice or something is slightly hindered or at least reduced because of the complexity of the standard of Microsoft Word Office documents. And so I think the complexity of agility and all the other things that we add upon the DMA should also slightly be reduced.
Agree. Again, paraphrasing another great mind, make it simple, but not simpler, because it's not going to work. So I think we agreed there, but also when we see through discussions that we're taking part, and you're going to see also with the next one, there's quite a bit of requirements that need to be tackled in order to have this successful. And there, absolutely, we should not make it more complex than what's needed, but if we try to make it simpler, it's going to end up being not good for anyone.
Any other question in the room? If not, we can take another one online. Don't think so.
Then I go for the last question from the online community with the most voted for the popular demand, which is, how do you deal with interoperability when additional features are used, for example, disappearing ephemeral messages or emojis and animations embedded into text?
I can take that, as we've been doing this sort of interoperability for a while now. And you basically need to provide either a fallback representation, so that if somebody tries to do something to you that your client can't understand, like, I don't know, a custom emoji or something, then perhaps it needs to be turned into an image or a sticker or something. However, if it's a feature like disappearing messages, first of all, everybody needs to understand that disappearing messages or exploding, self-destructing messages, whatever you call them, is always a best effort thing. And any user who thinks that the other guy is not taking a photo with their phone or a screenshot of their phone in order to get around the guarantees, or the so-called guarantees of disappearing messages, is lying. So in order to mitigate that, the bridges which are conversing between the protocols need to be aware of those sort of semantics and do their best to uphold them. And then finally, if it's a feature that just doesn't exist at all, say the virtual world one, that somebody goes and upgrades your chat room into a virtual world. As I said earlier, something that we can do today. First of all, you can see the chat messages in that world. You can also voice call into that world and hear the people chatting in it. And what we do is to, for instance, upload the 3D assets that make up the world as file attachments in that chat room. So you can go and download them and view them to see what's going on as like a really low fidelity metaverse client where you keep downloading files and then opening it and saying, oh, somebody moved from A to B or whatever. So it's that sort of fallback representation. Or in the end, you chuck them a URL and say, hey, I'm doing this cool feature. If your client doesn't know how to render virtual worlds, click on the link and get taken in. So it's actually a positive outcome in some ways for the gatekeepers in that it's allowing them to differentiate on unique features that they only have on their platform. And if other people haven't yet caught up for interoperability, then obviously there's a reason to actually use the gatekeeper's service.
Just very briefly, I think it provides actually quite a good segue, if I'm not stepping outside my bounds, to the next session. I think we've talked about innovation here, and the reason why basic functionality was one of the touchstones of the DMA was precisely to enable, as Matthew says, other apps to differentiate themselves. I think the important thing from our perspective is that users understand that, right? It's all well and good having a fallback or some other provision, but users, I think, need to understand what it is they're getting from an interoperable service that they don't necessarily, like that they're used to in a first-party messaging service that will look and feel and potentially be different in an interoperable space. And I think we'll touch on that in the next panel.
Eric, maybe first.
I think that questions like this around which networks support, or which apps support which features are slightly red herrings and just thrown into the mix to make things seem more complicated than they are. For example, earlier this year, WhatsApp added emoji reactions to their app, right? Which wasn't supported for, forever, even though most other applications had them years before. Beeper supported that within a couple days of the first release, I think on Android, far before the native iOS app for WhatsApp actually supported emoji reaction. So I think that you'll actually see more innovation when you have interoperable services like this, because it's possible for other people to extend the service to actually add new and more interesting capabilities.
Yeah, thank you for both raising the point on extensibility of the protocol, because that's key to how we develop whatever common protocol we use, and with that also comes discoverability of whatever is supported. So backwards compatibility is important, or at least graceful degradation. But I wanted to also pick on one of the comments that you made about these exploding messages, or whatever you call them. I think Stephen's point was that every message that would leave their system would basically also be best effort. And I wanted to understand what your reflection, the rest of the panel, is on that specific point, that once a message leaves one's own system and it goes to some other system, that some of those guarantees might, be harder to, guarantee.
Okay, I just have I know you asked everybody but me, but I'm still going to answer first quickly.
All of us.
All of us. Okay, even better. There's a really good precedent for this, which is WhatsApp. Because when you go and talk to somebody on the WhatsApp business API, I believe that you get a little pop-up at the top of the screen that says, by the way, your messages aren't end-to-end encrypted anymore. For more information, click here and read our T's and C's. So we've got however many, 2 and a bit billion people already using services which educate users to understand when they are leaving the safety of the default silo because they're going somewhere slightly different. So whether you're heading out to the WhatsApp Business API offering or whether you're heading out to, I don't know, Matrix or XMPP and, by the way, user, you are leaving the Citadel, some bets may be off, you got to trust who you're talking to. There literally is that precedent already to educate users that that's how the world works.
I'm going to go in the opposite direction, which is to say that I think if this is done properly, then the user shouldn't have to be concerned about their message leaving the safe enclave, right? That's the whole point of these few words in the DMA. So I think in terms of basic functionality and being able to, provide the same security guarantee that the originating app already provides, we have failed if we have to inform the user of something changing, right? I just don't think that's really an optimal solution. Now, for sophisticated users in business context, or if there's some particular security feature that you signed up for, which is not supported by the interoperating service, that's a different story. But I think kind of baseline level, it should be like TLS. You shouldn't have to be thinking about which flavor of it is being delivered or who the terminating service is. I will also say something else, just because there was so much discussion about user interface this morning. Let those user interface interactions be guided by the gigantic body of existing research about how users understand security dialogues. It's very easy to throw up a mock-up and say this is what this could look like, and it's completely uninformed by what users actually internalize via security dialogues. So I would hope that in the instances where users do need to be informed of some change that's occurring, that it's informed by everything that we've learned over the last decades about what people actually internalize.
Maybe just a comment on the WhatsApp Business API point, because I think it makes quite a good sort of example of what we're talking about here. Because, Matthew, you're right. In certain instances, the WhatsApp Business API, when it's managed by a third-party service on the business side, that's why there's that message to inform users is that it's no longer protected by end-to-end encryption, because, as I said, we can't guarantee the security of all the endpoints. If it's the business itself managing at the third-party side, if it's the business itself managing the communications on their own behalf, then that promise is kept, right? The end-to-end encryption promise that I mentioned that is on the top of personal message threads is kept, and that's the distinction there, because we can guarantee the security of the endpoints when it's the business itself rather than a third-party service managing on behalf. So I think that it is an example of where users are potentially certainly in our view, would need to be aware of the differences in those contexts. I know we'll come on to, I think, quality of service in the next session. I wasn't sure if that was what people were also touching on in terms of when there's a message handover, how can we guarantee that it, reaches the other end? Maybe we can touch on that. A question in my mind that, from a legal perspective as well, comes up is outages. There's certain outage reporting obligations for NIC services now across the EU, and that's relatively understandable in a closed model where if it's an outage, it's probably WhatsApp's fault somewhere. But in a third-party interoperable world, how do we decide who bears the responsibility for those kinds of things? It's an open question in my mind. If anyone has an answer, I'd love to hear it.
I don't. I think I would make 2 points here. One, as someone spent much of their career working on security, the minute the message leaves your computer, all bets are off about what the security properties are. You don't know the other person's machine isn't infected. You don't know the other person doesn't have antivirus or DLP software, which is inspecting the memory of the software. So even if you have an entirely closed system like WhatsApp, the guarantees you have about who actually sees the data are are somewhat limited, which I think the point was Matthew was making also about taking a picture of disappearing messages. But with that said, I think that, as Alyssa said, if we do our job properly, and these systems are secure with end-to-end protocols that are designed properly, then the security provided by having by messages which transit the gatekeepers network to the access seekers network should have similar security properties to those that stay solely within the gatekeepers network. And if that doesn't happen, then things have gone wrong somewhere.
I mean, I agree in the ultimate end goal for sort of everybody consolidates on the same protocol perspective, then you would hope that the same security properties would be present everywhere. But just pragmatically, today, if you imagine that people were using this, say that you got a bunch of people who have consciously decided to use WhatsApp because they really trust Meta as a company and they like the security guarantees and they hate Telegram. And let's assume that Telegram's been designated a gatekeeper. We're not sure whether we do trust Telegram necessarily to make the highest quality clients because they lie about end-to-end encryption and all that sort of good stuff. And then somebody goes and adds somebody on Telegram into the group chat. Surely you want to be told, by the way, heads up, this has now become a heterogeneous thing and there are different people on different services present. And that might be fine, it might not be fine. It just feels like basic education.
Yeah, I'm just assuming for this scenario that that this doesn't meet the requirement of the DMA from WhatsApp's perspective.
Sorry. I mean, I know that Paul still wants to intervene, but we are already a bit over the time. So I would suggest that maybe we, break it here, have a coffee and continue, because Stephen was already very much engaged into the third panel. So I think we need to start very quickly. And thank you very much for a very, very interesting discussion to everyone.